Hey everybody, and welcome back. This section is super important. Today our goal is to be able to differentiate any composition of functions. So we kind of have been able to do this before when we talked about the quantity of x plus 2 squared, taking the derivative of that. You could expand it and find the derivative, but really we don't want to do that all the time. We want to be able to use some sort of shortcut for finding our derivatives. So let's see what we have here. So here's one of the best ways that I can think of to explain an illustration of the chain rule. So if we're driving up a mountain in a car, right? There are going to be two functions. One of these functions is going to be the temperature at any height on the mountain, right? The other function is going to be the height of the car at any time. T prime of h is going to be the rate of change of the temperature with respect to the height. So in this case, we would have T prime of h would be equal to dt dh. If I look at the units on this, my temperature, let's say my temperature is measured in, we're not dumb, so we're going to use degrees Celsius, per my height on the mountain can be measured in meters. So it would be degrees Celsius per meter. And we would be able to measure that by the change in the altitude and the change in pressure and everything would cause the change of the temperature, right? So our other one that we have, the h prime of t, would be something like, using Leibniz notation, dh dt, right? So dh dt would be essentially our change in our height is the meters, and the time we could measure in seconds, right? So we would have the rate at which you're climbing that mountain would really adjust that. So we're talking about how fast you're driving this car up the mountain, but we're only concerned with the height because that's what really causes the temperature to change. So now we can actually find the rate of change of the temperature with respect to time. And a couple of different things that we would label that as capital T prime of t. We could also think of it as d capital T dt. And that's how quickly the temperature is dropping over a matter of time. That's going to be important because we have to know when we're going to put our sweater on. So the ways that we could calculate this, I will point out that one thing, before we get into how to calculate it, oh my goodness, we would have the change in the temperature would be degrees Celsius per the change in time would be seconds. So one way we can think about this, we can think of this as what's that called? Dimensional analysis problem, where we have the degrees Celsius per meter times meters per second. That's going to work out and give us that degrees Celsius per meter, or per second rather. Looking at that degrees Celsius per meter times meters per second cancels out and gives us that degrees Celsius per second, degrees Celsius per second, right? The other way that we can look at this, we can use the actual Leibniz notation. We can have dt dh times dh dt. Remember, I've told you repeatedly that these are not fractions unless it's convenient for us to think of them as such. In this case, it is convenient, so we can cross off the dh's, and we're left with dt dh. So what we have to look at here, in order to use the chain rule, we need to look at two different functions, where we have the t of h and the h of t. We're going to essentially be taking the derivative of our outside function and multiplying it by the derivative of our inside function. It looks complicated, and sometimes people think it is, but we'll get there, all right? So here, you're going to need to know the chain rule. The chain rule says dy dx is dy du times du dx. The derivative of y with respect to u times the derivative of u with respect to x. If f of g is the composite of y equals f of u and u equals g of x, then f of g of x prime is equal to f prime of g of x times g prime of x. And again, we will get to what all of this stuff means. It looks complicated, and is kinda, but we'll get there. All right, so the next thing that we're gonna do, we're going to apply this chain rule. And again, I understand that the stuff that's on the board right now looks confusing. Again, it is, but with practice, it gets better. So, we are going to try to find the derivative. I don't know why the page didn't advance. I told it page down. It just didn't listen to me. We're going to be trying to find the derivative of f of g. In this case, we have f of u is equal to sine of u, and u is g of x, which is x squared minus 4. Essentially, what we are trying to do, we are trying to find the derivative with respect to x of sine of x squared minus 4. That's our ultimate goal. What is that? That's what we're trying to answer. One way to do this is to split the two functions up into f of u and u, which would be g of x, which is x squared. And we're going to find this at x equals 2. All right? So one way of doing this, the chain rule, tells us that the derivative of f of u is going to be f prime of u. And if we want to find the derivative of f of x, we have to multiply that by g prime of x. So a couple of things that I want to figure out before I actually evaluate this. I can keep this a little bit organized, I hope. I hope I can find f prime of u. I hope I can find g prime of x. And I hope I can find x and u. Right? So there's the four things that I want to find and eventually plug stuff in. So f prime of u is going to be equal to, let's see, f prime of u. Here's f of u. So f prime of u is going to be the derivative of sine. If I remember that correctly, it's cosine of u. With me so far? Good. G prime of x is going to be the derivative of x squared minus 4. Derivative of x squared is 2x. Derivative of 4 differentiates out, so we have 2x minus 0. I'm not going to put the 0. I believe I know what x is. 2. And u is, let's see, u is going to be x squared minus 4, so that'll be 2 squared minus 4. 2 squared 4 minus 4, 0. With me so far? Okay, cool. So here, I'm going to have f prime of u. F prime of u. F prime was cosine. Cosine of u is 0 times g prime of x. G prime is 2x. X is 2. So this would be 2 times 2. So we've got cosine of 0 times 2 times 2. Well, cosine of 0, and I think I've told you guys this before, I have to use the inner circle every time I'm doing it. I know I'm talking about cosine of 0, so that's right over here. I've got 1 comma 0. Okay, cosine of 0 is 1. I've got 1 times 4. The answer to this is 4. All right? And just to be clear on this, we again can use our graph and calculator to figure out if we're actually right, if we're in the right ballpark here. Again, we happen to know that this function is differentiable at x equals 2. So let's see. I want to find the derivative of sine of x squared minus 4. So alpha window and derive of x sine of x squared minus 4 at x equals 2. Fingers crossed it's 4. 3.999989333. That looks pretty much like 4 to me. It's pretty close, in the right ballpark. Again, when you're using n-derive, sometimes it's a little bit off, but we can round to the nearest, what, millionth or whatever that is. All right? Cool. One other way to do this type of problem when we're talking about the composition of functions is what I call the outside-in method. And the outside-in method, again, I said, go to the next page, there we go. We are trying to find the derivative of sine of x squared minus 4. So the first way was finding f prime of u, g prime of x, and multiplying them together, back sub in. The other way to do this, when I want to find the derivative of sine of x squared minus 4, this requires that I know what the outside function is and what the inside function is. The outside function here is the trig function. When I'm doing the outside, I'm going to keep the inside the same. So the outside is sine. The derivative of sine of something is cosine of the exact same something times the derivative of that something. Now I see that I still have derivative in the problem that I'm trying to do, so I'm going to have to take that derivative. So this is going to be cosine of x squared minus 4 times the derivative of x squared minus 4. Derivative of x squared minus 4, 2x, 4 differentiates out, and then I'm just going to rearrange stuff so that it looks pretty. 2x cosine of x squared minus 4. That is the only rule we are learning today. Nothing else other than what is called the chain rule. When we're dealing with the chain rule, we have certain pieces that we call the chain. The chain is the derivative of the inside function. All right? Again, I know this looks complicated. More practice makes it go more better. Ooh, boy. Here are 4 derivative problems that we want to do. All of them are chain rule problems. Move them all over to the side just so that they're not messing with stuff. I'm just going to run through these. Hopefully you guys can keep up with me. We're talking about the derivative of sine squared of x. This is one of the ones that causes, or one of the types of problems that causes all sorts of crazy difficulties with these. We know that when we're talking about sine squared of x, the derivative of sine squared of x, we know from trig that squared means we're taking sine and we're squaring it. Essentially, it's like sine of x times sine of x. So an alternate way to do this problem would be to do the product rule on sine x times sine x. All right? We don't want to do that. We're thinking of the squared as the outside function. The sine is being squared. So the first thing that we have to do, again, I'm looking at this as the outside in. So the outside function is something squared. The derivative of something squared is 2 times the something. All right? Now we look at this. We still have to find the derivative of the something. The something that we just brought up was sine of x. 2 sine of x times d dx of sine of x. We still have derivative notation in here, so we have to calculate it. 2 sine x times derivative of sine of x, cosine of x. The derivative of sine squared of x is 2 sine x cosine x. And I'm not going to do this for every single problem, but here's a nice way to check yourself. You can go into the y equals menu here. Let me clear out this stuff that we were using in class today. Clear. We ask the calculator to differentiate the original function d dx of sine of x squared, and we should remember from trig that that's how we actually have to put in sine squared into our calculator, because our calculator, again, is a dum-dum. Then we put x. So basically I'm asking the calculator, what does the derivative of this look like? And in y2, I type in what I think it looks like. 2 sine of x times cosine. That's not the right one. Times, I said, cosine of x. And if I was to graph these as oof, okay, that didn't work. Apparently we need to use a better zoom window. I think I was zoomed in way too far. So as long as everything comes out right, these two graphs should be coincident with each other. Notice blue is the derivative, and then the red is the graph that the function that I thought it was. And we can see, since both of these functions are exactly over top of each other, that I actually have the right answer. That's wonderful. Now again, I understand that this is difficult. It's the first time you've done this. You might like doing this a little bit different if you look at this as f of u is equal to sine of u, where u is equal to, no, that won't work. Because what I want is the f of u to be the outside function. We said that the outside function was u squared. So I've got f of u is equal to u squared. U is equal to the sine of x. So now I can actually use that whole Leibniz notation of the chain to say the df dx is going to be df du times du dx. So in this case, df du is going to be 2u times du dx, derivative of sine of x, would be cosine of x. And now I have two variables. The only thing left is to sub that u back in. So I've got 2 sine of x, cosine of x. I don't care which way you do this, whether you declare your f of u and your u, or if you do the outside in. I will say with practice, the outside in method is a little bit easier and a lot bit faster. You might want to pause, give number 2 a shot, and then come back to me. I'm going to do it in blue just to keep it separated. And to mix things up a little bit, I'm going to switch the order in which I do these. I'm going to do the f of u and the u first, and then I'm going to do the outside in, to try to really drive that home. So the first way that I look at this, I can see that f of u, the function that has another function plugged into it, is going to be cosine of u. Where u, what's being plugged into the cosine, u is 2t squared plus 3t minus 4. That's what u is. Side note, that just makes me chuckle every time I say it, because I want an English teacher to hear me and just watch their head explode. So now the ultimate question is, what is df dx? No, not df dx. I looked at that and realized that the independent variable is not x, it was t. That would make no sense if I called it df dx. It's df dt. So df dt is going to be df du, the derivative of f with respect to u, times du dt. If I look at these two functions, they're not difficult to differentiate. Derivative of f, cosine, gives me negative sine of u, times derivative of u with respect to t. Just take the derivative throughout here. 4t plus 3. Taking it one step further, because I see I've got sine of u and a t, I want the answer to be in terms of t. I'm just going to plug that u back in for, plug in that for u. So I can have this as, rearranging it a little bit, negative 4t plus 3. I always like to put the polynomial out front. Sine of 2t squared plus 3t minus 4. And then I can be done. If I'm doing the f of u and the u is kind of thing, that's the way that I want to do it. But again, I personally don't like doing it that way. The way that I like doing it, I just start out. If I was doing this problem, I would not have written all this stuff. You can if that makes more sense for you. When I do it, I write down the original problem, d dt of cosine of 2t squared plus 3t minus 4 And again, I go outside in. The outside function is cosine of something. Cosine of something differentiates to negative sine of something. And when I say of something, I just mean all this garbage in here. All right? The 2t squared plus 3t minus 4, that's just bundled up in the variable that is called something. So derivative of cosine of something is negative sine of something. Times the derivative of that something. So now I'm keeping in my mind, again, I'm using variables like in terms of computer software, computer programming. The variable something stands for 2t squared plus 3t minus 4. So the derivative of something is going to be 4t plus 3. You can see it's pretty much the same answer as before. It's just the arrangement of it. This arrangement is not pleasing to my eyes. I would call it negative 4t plus 3 sine of 2t squared plus 3t minus 4. And then I would be done with that. Okay? So again, I would prefer personally, this is just a personal decision. There's nothing wrong with opposing me on this one. I personally think doing the second line is easier for me. This first line might be easier when you're learning this, all right? So we're going to do 3 now. If you want to try 3, pause the video and then come back. All right, so looking at 3, if I'm doing it with the f of u and the u, wait a second. This looks more like a quotient rule problem, doesn't it? My goodness, I could just do this with quotient rule, couldn't I? Low-D high, high-D low, low-low. That is one option. The other option, when you see just something in the denominator like this, I like using this trick because I think I told you guys when I taught you the quotient rule earlier this week or last weekend, as it may be. I hate the quotient rule. It just never works. Well, it works for me, but it's a struggle. So I don't like struggles. So when I see something where you just have a denominator and some sort of constant in the top, I mean, if this was like 2 over 2x squared plus 3x squared, 2 over 2x cubed plus 3x squared, I would just put the 2 out in front, and then I would do this exact same thing. So this is really when there's any constant in the numerator here. So looking at this, I now look at this as my f of u is equal to u to the negative first. My u is going to be 2x cubed plus 3x squared. If I want to find df dx, I'm going to look at this as the df du times du dx, right? And again, since I have these laid out, they're not really that difficult to figure out. Derivative of u to the negative first, well, I drop the negative 1 down. Negative u, negative 1 minus 1 gives me negative 2. Negative u to the negative second times derivative over here. Derivative of 2x cubed, okay, 6x squared plus derivative of 3x squared. I guess that's just 6x to the first, right? And again, rearranging stuff, making it look as pretty as possible, and plugging the u in all at once. This part is really just algebra. I see a negative exponent. That's going to go on the bottom as a positive exponent. And it's going to be u squared down there. And u is 2x cubed plus 3x squared. Numerator is still this gobbledygook up here. 6x squared plus 6x. I would not go any further than this. I would leave it right here because it looks as pleasing as possible to me. Again, if I was up here doing the outside in method, I can probably squeeze that in right here. I would call this the outside function is the negative first power, so I would have negative 2x cubed plus 3x squared to the negative second times the derivative of the something. So again, we had something to the negative first, The derivative of something to the negative first is negative something to the negative second times the derivative of a something, which would be 6x squared plus 6x. It does not matter to me which method you use, whether you use the one that I like after a lot of practice or the one that might be a little bit easier to navigate without as much practice. It is all personal preference at this point. And let's do number 4. So you can see magically I have number 4 drawn up there for you. Because this one's like such a simple problem, I don't feel like doing the f of u and the u part of this. I'm just looking at the outside. And the outside is the one that has something else plugged into it. So I can see I've got cosine of something. Notice this is cosine of something. This is a little bit different from the sine squared that we had in number 1. Here, the outside is cosine, so the derivative of cosine is negative sine of the something. Again, something is a variable that just stands for 3x, times the derivative of something. Again, I'm keeping in my head what something is. It's 3x. The derivative of 3x is 3. This arrangement up here is just abysmal. You never want the number after the sign. You just want negative 3 sine of 3x. And there I'm done. Again, there's the outside in to make it just a little bit easier, a little bit quicker to navigate. All right. So something that I can point out to you guys. Your derivative formulas already have the chain rule in them. N u to the n minus 1 times du dx. Derivative of sine of u is cosine of u du dx. What we're acknowledging here is anytime you have sort of interior functions, you have to multiply by the chain. The biggest thing that I see people messing up on taking derivatives is forgetting the chain. Don't forget the chain. The most common mistake on differentiation is to forget to use the chain rule. So always be on the lookout for composition of functions. Practice, 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 practice. I mean, even if we wanted to talk about d dx of x squared, the derivative of x squared is just 2x. And then you can always think that you have a chain in there. You can think your interior function is just x. So you multiply by the derivative of x. Derivative of x is just 1. So yeah, you can always apply the chain rule, although like in this situation, it's just a little bit wackadoodle to do. Wackadoodle do, what we can say. Let's muck this up even further. Let's find second derivatives on these. So we can find second derivatives, third derivatives, fourth derivatives, sixth derivatives. Yikes. Any derivative that we want. So I don't want to do all of these just because it's going to get a little bit tedious. Let's go to one that actually has a chain rule involved with it. So I'm talking about like number 3. Number 3 looks absolutely awful, doesn't it? So on number 3, I know that I've got f of x is equal to 1 over cosine squared of x. I'm going to rewrite that as cosine of x to the negative second. Again, recognizing that that squared just means I'm taking cosine and multiplying it by itself. The 2 being in the denominator means that I have, or the square being in the denominator means I have a power of negative 2 here. So when I find my f prime of x, I'm going to go with my outside in strategy. My outside is just that negative second power. So the derivative of something to the negative second power is negative 2 times the something to the negative third power times the derivative of the something. Derivative of the something, derivative of cosine would be negative sine of x. Now I know I'm going to have to find the second derivative of this, so this looks just awful for me to write it like this. I am now going to go in and I'm going to clean it up. I've got 2 cosine x to the negative third times sine of x. All right, cool. I could even use my trig rules to try to simplify this some more, like that negative cubed, I can put cosine on the bottom. I'm seeing that this is looking like tangent, or 2 times tangent times secant squared, if I wanted to go that route. But that's really just going to muddy things up. I'm just going to stick with this one. So now I see I've got a product and a composition. So using the product rule and the chain rule, I'm going to find the derivative. So f double prime of x is going to be equal to, if this 2 gives you any sort of trouble, forget it. It's 2 times the derivative of the rest of this stuff. Now the derivative of the rest of this stuff might be a little bit difficult. We've got left cosine of x to the negative third times derivative of sine. Left d right. Derivative of the d right is cosine of x. Plus, we did left to right, now we got to do right to left. Sine of x. And here's where we might run into like some ickiness. The ickiness here, I see I've got a composition of functions again. I'm going to have negative 3 cosine of x to the negative second times negative sine of x. Whew, that looks ugly, doesn't it? Well, we can fancy it up a little bit. We got 2 times a quantity. Looking here, I've got cosine to the negative third and cosine of x. Since I have the same base, I can add exponents. Negative 3 and 1 gives me cosine of x to the negative second. Negative and negative gives me positive 3. Sine times sine gives me sine squared of x times, that should be to the negative fourth. My goodness, negative 3 minus 1 should give me negative 4. Cosine of x to the negative fourth. I don't think I would mess with that anymore. Maybe those negative exponents I can put on the bottom, but I don't really feel like doing that right now. We'll practice some more second derivatives tomorrow. But here's the assignment. I would encourage you to do some of these practice problems before tomorrow, just because chain rule can be tricky. Yeah, so see you guys tomorrow.